Hi everyone and welcome to part 2 of activity 6. Today we are going to talk about function operations. Reminder with our function operations, we are either adding together two functions, so f of x plus g of x. We are subtracting two functions, f of x minus g of x. We are multiplying two functions, f of x times g of x, or dividing. In this case, f of x divided by g of x. Now be careful with function division. Reminder, we do not want our denominator to end up equaling 0 at times. We'll talk more about this later in the lesson, but this is going to be the idea of some domain restrictions on our functions to make sure that they exist. And then the domains of the x values are that in the domains of both your original functions f and g. So if we look at number 4, we have three different functions, f of x, g of x, and h of x, and we are going to perform some of those operations. So for the first one, we're taking g of x, and we are adding to it h of x. So in this case, we end up combining like terms. So 7x, plus the 3x. And so we have 5x squared plus 10x. And then negative 2 minus 1 more is minus 3. So we have that sum of g and h. The next one, we are taking h and we are subtracting away from it g of x. Reminder, when we subtract, we need to distribute that negative to all pieces of that function. So we actually end up with 3x minus 1 minus 5x squared minus 7x plus 2. And then again, we end up combining like terms. So we have negative 5x by its 5x squared by itself, 3x minus 7x this time is negative 4x, and then negative 1 but plus 2 is plus 1. Our next one is having us multiply function f and then times function h. So reminder, we need to make sure we double distribute, FOIL this out. We end up with negative 4x times 3x, so we have a negative 12x squared. Negative 4 times negative 4x times negative 1 is positive 4x. And then we also are going to distribute that 3 through, so we end up with 9x squared minus 3. And then last but not least, we are going to combine those like terms. Negative 12x squared plus 13x's minus 3 would give us our product. Last but not least, with the division, f of x is negative 4x plus 3. H of x is 3x minus 1. And this is just basically as good as that quotient is going to get. Nothing else to simplify there. Now, if we look at these three original functions, f of x, g of x, and h of x, all three of these are polynomials. The first one is a line, the third one's a line, and then we have that quadratic. So we know for all three of these, our domains are all real numbers. From negative infinity to positive infinity, there are no x values that are going to mess with these graphs. Our domains are going to just be all real numbers for x. Therefore, our domains of our new functions are also going to be all real numbers, or from negative infinity to positive infinity for those x values, except for that last one, f divided by h, because we know that that h of x function in the denominator cannot equal 0 because there's no division by 0, or otherwise we get an error message, right? If we take our calculators and we look at any function, I mean, even just 1 divided by 0, that's going to cause us to have an error message that we don't want. So cannot have that. So if we look at this function, right, if we check out this function, we know that the denominator, which is 3x minus 1, it cannot equal 0. So what we end up doing is kind of solving here add over the 1, divide by 3, we end up finding out that x is not allowed to equal 1/3. So oftentimes you're going to see that represented like this with the curly brackets there, and then it says x such that all real numbers are going to work for x, except x is not allowed to be 1/3 or it causes an issue for us. Well, let's look at this last page of the notes and talk a little bit more about our domain restrictions each time. So again, when we see some of these functions like part A, all right, we want to make sure that our denominator does not equal 0. So essentially that's what you're kind of doing, is almost setting it equal to 0 to figure out what would make it have an error. So in this case, we're going to subtract over the 24, divide by 8. We find out this time that x cannot equal -3, or again, we would have an error message. So for instance, if we had -3 stored as that x value, and again, we had the top of the fraction was 8x plus 8 divided by, not xx, 8x plus 8, and divided that by the 8x plus 24, we're going to see that we're going to get an error message because we had that division by 0. So again, -3 causes us the issue, so we would say that cannot be in our domain. All right, the second one, when we set that denominator not equal to 0, right, we're going to say, hey, where is this going to cause us an issue? We see that we actually end up needing to factor because we have a quadratic and we want this to multiply to equal -8, add to equal +2. Well, that's going to be x plus 4 and x minus 2. And again, we want to know, where is this going to cause us an issue? Where is it going to make us equal 0? So when x equals -4 or +2, again, that is what's going to cause us the issue. So this time we have two values that are going to be exempted here, -4 and +2. All right, the next one is an example of a square root function. Now, we are able to take the square root of 0, right? That works out. However, we are not able to take the square root of anything that is negative. We get those imaginary answers if we do so. So essentially for the square root functions, we want these to be greater than or equal to 0 because then our function will exist. So we add over the x this time, and we want our x values to be less than or equal to 5. So in this case, for instance, if we took like 5 minus 5, we see this works out. Or if we took 5 minus 4, that's okay. But if we did, 5 minus 6, a value bigger than that, again, that's where we're seeing that. So this time, our domain would be all of our x values less than or equal to 5. Okay, last but not least, this time with our square root function, it is in the denominator of our a quotient here. So this time, 9x plus 72 cannot be greater than or equal to 0, because if it equals 0, we would have an arrow on the bottom. So notice that this is just a greater than versus the or equals to we had in the last one, slightly more of a restriction. So this time we're going to subtract over the 72. And when we divide both sides by 9, we end up with our x values needing to be greater than -8 this time. Again, not or equals to, because otherwise we are going to get division by 0 since this is a quotient. All right, there are two final examples for you to try. You are going to state the domain restriction on part A as well as the restrictions on part B. Thanks everyone for watching. We will work more with these in class.